Hey, Mr. Westwater here, about to take you through paper 2HR from June 2022. And away we go. So, question one. Now, these are actually rare things now. It's all about transformations of shapes. These don't come up that often, but they used to come up every single paper. So let's just have a look at this. So it says, describe fully the single transformation that maps triangle A onto triangle B. Now, one thing that's worth noting is that this is worth 3 marks. So we need to give at least 3 bits of information here, right? So this to me looks like a clear enlargement, and one thing we can do is we can use straight lines, or in fact it's not the best. Let's get my ruler. How can I find? Here we are. I can get my ruler out and I can connect points like this. Okay, not perfect, but it'll do. Okay, like this, and if I do this for all of the vertices, let's just drop that down a tad more. Right, there we are. This is the bottom left corner as well. We can see that they're all actually going to pass through the exact same point here. Let's get rid of that ruler now. At 3, 0. So this is an enlargement. Okay. Now that's our first of the 3 marks, but we need to give a scale factor. So this is going from being 1 square wide to 3 square wide, or 2 squares high to 6 squares high. So our scale factor, what are you timesing those by, is 3. And we have a center of enlargement at 3, 0. Okay, 3 points for 3 marks. And then on the grid above, translate, so that's where we shift it, triangle A by the vector -4, 3. So in vector form, the top number represents how many you're going to the right, and the bottom represents how many you're going up. So if it's -4, this means we're going 4 to the left, and then 3 up. So let's just take this bottom left-hand corner. We're going 1, 2, 3, 4 to the left, and 1, 2, 3 up. We can do this with all the points. 1, 2, 3, 4, 1, 2, 3, and 1, 2, 3, 4, 1, 2, 3. It should look exactly the same as the shape we started off with. It's asked us to label it triangle C, so I'm going to label it triangle C and say thank you very much for my 4 marks. Okay, on to question 2. Write 1200 as a product of its powers of prime factors. Show you're working clearly. Now this is important because your calculator can actually do this for you. If you put 1200 in your calculator and then do shift and then hit fact, it will tell you that the answer is 2 to the 4 times 3 times 5 squared. So that on its own will actually score no marks. Even though I know that this is the final answer, I might as well write it in. Okay, and at least I know that's what I'm trying to get to. So what it's looking for is a method. Now there are a few different methods you can use. This, I like the sort of cherry tree approach, so I'm going to break it into various steps. So this is 2 times 600, and every time I get a prime number I'm going to circle it. I'm going to stick with the 2's until I can't divide it by 2 any further. 2, 1, 500, 150, and 2, 75. Maybe I should have done this a little bit smaller. Let's just make this a little bit smaller. I know you're unable to do this, but okay. So we're up to 75, and now 2 doesn't go into this, but 3 does. 3 times 15, I think. No, 3 times 25 goes into this. This is prime, and 25 breaks down into 5 times 5. So we've got 5 squared, 2 to the 4, and a single 3, which is where our answer comes from. Okay? On to question 3. Alberto, Bill, Candela, and Diana are 4 friends, here is some information about the height of each of these friends. So Alberto's height is 158, Bill's height is 175, and Candela's height is greater than Diana's height. Okay, so we've got 158 for Alberto, we've got 175 for Bill, and Candela's height is greater than Diana's height. So essentially, our C and D, for lack of a better descriptive thing, could go in a few places. If Candela's height is greater than Diana's, we could have C and D here. We could have C here. We could have C here. We could have D here, or we could have D here. Okay, so there's lots of different combinations that we could potentially have, but we know that the median of these 4 friends is 160. So straight away that tells me that either we've got them both in here, where the median of 160 is between them, or we've got this situation where Candela's here, or we've got this situation where Candela is on the outside over here, because if it was this way round, then the median would not be 160 in between these two. Okay, and the range of heights for these 4 friends is 21. So let's do a couple of hypotheticals. Let's say this can't be the case. If it were this way round, D and C, well then our range would be between these two, but this does not have a range of 21. In fact, 175 minus 158 is 17, so this wouldn't work, so we can rule out that combination as well. Secondly, if it was this way round, if we had a D and a C this way round, then if our median is 160, Diana would have to be 155 in here, because that would then mean 160 is halfway between them. But if that were the case, then actually this would have to go here, and it would change the median, because the median would now be between 158 and 175, and therefore not 160. So no, that doesn't work either, which leaves us with either C and D going down here. In fact, actually that's not going to work, because again, the median here would now be less than 158, so it leaves us with this situation where D is going to be this value at the bottom, Candela will be this value in the middle. So if the median is 160, in between 158, Candela must be 162. It's 2 either way of that 160. And finally, so let's put that in, 162. And if the range is 21, then 175 minus 21 is 154. That must be Diana's height, because then our gap is 154. So you could have approached it in a number of ways, but this is the only way that actually works. Okay. On to question 4. Okay, we've got all of these numbers, the numbers from 9 up to 20 inclusive. A are the multiples of 3, and B are the odd numbers. If you want, you could write out what all of these are. 15, 18. All the odd numbers. So 9, 11, 13, 15, 17, 19. And we're looking for the members of the set A intersect B. So that's anything that's in A and in B. So that's 9 and 15. Okay. Now the union is anything that appears in either of these. So 9, 11, 12, 13, I'm just working up in order, 15, and then 17, 18, 19. Again, I've misjudged the amount of space I've actually got for this. 17, 18, 19. Okay. Is it true that 24, now this symbol means is an element of, is basically in the set A. Now, if A is the multiple of 3, then 24 is a multiple of 3. However, I'm going to tick the no box because for it to be in A, it's also got to be in our universal set, and our universal set does not go up to 24. So give a reason for your answer. 24 is not in the universal set. And finally, set C has 4 members such that C intersect not B. So if we think about it this way, here's C and here's B. C intersect not B is going to just be this area here, so not including this intersection area. Okay, and we're told that that has the elements of 10 and 18. And we're also told that C has 4 members, which means that there must be 2 elements in the intersection of C and B. B has quite a lot of elements. It's got 9, 11, 12, 13, and so on and so on and so on. List the members of one possible set C. So as long as you've got 4 members, and a lot of people didn't put 4 members in here, but I'm going to list 10 and 18. They don't need to be in any sort of order. And then any 2 things from B, so I'm just going to go with the first 2, 9 and 11. Okay, that is a set C where we've got 9 and 11 in the middle, and the rest of B can be over here. Okay? Okay, on to question 5. So, the diagram shows a shape made of a square ABCD and 4 identical semicircles. As shown in the diagram, the semicircles have these diameters AB, BC, CD, and DA, and the area of the square is 36 centimeters squared. So what's going to be the length of one of these sides is going to be the square root of 36, which is 6, because 6 times 6 is 36. So square root of 36 equals 6. Calculate the total area of this shape. Now for each of these semicircles, the area of a whole circle is pi times r squared. So each of these is going to be a half times pi r squared. And if the diameter is 6, our radius is going to be 3. So a half of pi r squared is going to be a half of pi times 3 squared, or 9 over 2 pi. And we've got 4 of these. Okay, so if I times this by 4, we get 18 pi. And you can work out the decimal value of this if you want. 18 times pi, which is 56. 56.548667776 dot 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 going on. But then if we were looking at the total area of the whole shape, we need to add on our area in the middle. So add 36. Give your answer correct to 1 dp. This is going to be 92.548667776, or to 1 dp, 92.5. Okay, I always like to give a few more decimals before I give my final answer. On to question 6. Solve p equals 3p minus 5 all over 10. So the first thing I'm going to do is multiply through by the denominator. Whenever you've got an equation and there's a fraction involved, multiply through by that denominator. So times both sides by 10. 10p equals 3p minus 5. Okay, and I'm going to take away 3p. So 7p equals minus 5. And finally, I'm going to divide by 7. P equals minus 5 over 7. I'm not going to try and turn that into a decimal. I'm just going to leave it as minus 5 over 7. Okay. Part B. Pardon me. Simplify a to the power of 0. Anything to the power of 0 is 1. can do that on your calculator. 99 to the power of 0 equals 1. If you weren't sure, just pick a number. It will always give you 1 as an output. Simplify fully. 3xy cubed over 6x squared y. So here, the 3 and the 6 will cancel to become a 1 and a 2. X and the x squared, well, one of those x's on the bottom will cancel with that x on the top. And this y on the bottom will cancel with one of these y's in y cubed, leaving y squared. So overall, we have y squared still on the top, and we have 2x on the bottom. Okay? And finally, part D. Factorise fully. 10c cubed d squared plus 15c d to the power of 4. So I'm looking at the numbers here, and 5 goes into both of these. And c goes into both of these. D goes into both of these, but more than that, d squared, the lowest common power here is a d squared. So d squared goes into both of these. Now I'm going to open up my brackets. So what do I need to multiply 5 by to get 10 in my first term? I need to multiply it by 2. What do I need to multiply c by to get c cubed? C squared. And what do I need to multiply d squared by outside the bracket here to get d squared? Well, just by 1, so this will stay as 2c squared. And then I do the same for the next term. What do I need to multiply 5 by to get 15? 3. What do I need to multiply c by to get c? 1, so stays as 3. And what do I need to multiply d squared by to get d to the 4? D squared. Okay. On to question 7. Okay. Find an expression for x in terms of k and n when we have 2k over 4n equals 2 to the x. Here we're playing around with indices and we are trying to make everything into a common base. So the first thing I'm going to do is rewrite this as 2 to the k over 2 squared to the n equals 2 to the x. So now everything is in base 2. And when I've got 2 to the 2 and then to the power of n, when we've got brackets involved, we multiply these. So this is 2 to the k over 2 to the 2n will equal 2 to the x. Now, a lot of people made a very silly mistake here by saying, okay, so k over 2n equals x. But that is not how indices work. When we're dividing things, so if it was 2 to the 7 divided by 2 to the 2 cubed, we would subtract these. This would be 2 to the 4. So what I actually need to do here is say this is 2 to the k minus 2n equals 2 to the x. And now I've just got 2 to the power of something equals 2 to the power of something. I can say that k minus 2n equals x. That's going to be my answer. Okay? And let's just get rid of this for good measure. Okay. Question 8. A cinema increased the cost of an adult ticket by 12%. Before I read anything else, I'm going to make sure that I write out my percentage multiplier. So an increase of 12% is 1.12. After the increase, the cost of an adult ticket was £18.20. Work out the cost of an adult ticket before the increase. So I like to use my formula of my starting value times the percentage multiplier equals my final value. Okay, so here I'm told that after the increase, so the final value was 18.20. I don't know what my starting value was. Let's just call this x, and my percentage multiplier is 1.12. So if I do £18.20 divided by 1.12, 18.20 divided by 1.12, we get an answer of 16.25. So £16.25. The most common mistake here is going to be thinking, well, instead of timesing by 1.12, I'm just going to times £18.20 by 0.88 because that will represent a decrease of 12%. but we haven't been decreasing anything by 12%. We have been increasing something by 12%. And these are not going to be the same, because decreasing a larger amount by 12% will not be the same as increasing a smaller amount by 12%. In fact, if you did 18.2 or £18.20 times 0.88, you get 16.016, not this 16.25, because this is a larger amount, so you're taking 12% of that larger amount away. Okay? That's not correct. This one is. Okay. And on to our next question. Question 9. The table gives information about the population correct to two significant figures of each of 5 cities in 2018. So we've got Ahmedabad, Barcelona, Chicago, Lagos and Tokyo. Write 8.8 times 10 to the 6 as an ordinary number. So let's put 8.8 down here and whack a bunch of zeros after it. Now this is being made larger because it's a positive power. The decimal will move 1, 2, 3, 4, 5, 6 places. So that's 5 zeros, 8, 8, followed by 5 zeros. Let's put some commas in to give it a bit of context. This is going to be 8,800,000. Okay. Which of these cities has the least population in 2018? So here we're looking for the lowest power of 10. So we've got 3 times 10 to the power of 6's, because even though this is a smaller number, because we're timesing it by another 10, it's going to be 10 times bigger than 1.3 times 10 to the 6, and therefore bigger than any of these other values. Think about 3 versus 13, So 3 is 3 times 10 to the power of 0. 1.3 times 10 to the power of 1 is going to be 13. It's already comfortably bigger. Okay? So, part B, which of these has the least population? Well, it's going to be Barcelona, because this has the smallest number and the smallest power. For the smallest power, I should say. So, Barcelona. And finally, work out the difference between the population of Tokyo and the population of Ahmedabad in 2018. So, Tokyo. Okay, Tokyo and Ahmedabad. I'm going to do this without a calculator first, and then I'm going to do it with a calculator second. So I'm going to let's go. So we're going to do 3.7 times 10 to the power of 7 minus 7.7 times 10 to the power of 6. Okay. And to solve this, I'm going to make these both have the same power. So I'm going to change this so that it is minus 0.77 times 10 to the power of 7. So this number has been made 10 times smaller, so that I've been making this power 10 times larger. So we've got this as our calculation, and essentially we can factor out the 10 to the 7. So 3.7 minus 0.77 times 10 to the 7, which is 2.93 times 10 to the power of 7. We only want two significant figures though, so this is 2.9 times 10 to the power of 7. Okay, but you could have just used a calculator. You could have said 3.7 times 10 to the power of 7 minus 7.7 times 10 to the power of 6 is 293,000, and interpreted that in standard form. All right? On to question 10. Okay, so we have a regular hexagon, A, B, C, D, E, F, and we're being asked to work out, or in fact we were told AB is 5, BP is 2, and we're being asked to work out the size of A or PAF, this angle here. So I guess the easiest thing to do is work out what every angle in a regular hexagon is, and then take that away from, or take this angle in this right angle triangle away from it. So there's various ways you can work out the angle in a regular hexagon. You can use the formula of 180 times n n minus 2. So this would be 4 times 180, which is 720. And then do 720 divided by 6 for 120 degrees. So each of these is 120 degrees. The other way, which is actually the way I would have done it, is to just say external angles are all sum up to 360. So if we do 360 divided by 6, that is 60. So my external angle is 60 degrees, and therefore my interior one's going to be 120 because they will sum to 180. So anyway, that's part 1. Now in part 2 I'm just going to take this right angled triangle of 5 and 2 and work out this angle here. So we're going to be using basic trig here with my opposite and my adjacent. So in sew, car, tower, the thing with the opposite and the adjacent is the tower. So tan theta, let's call it, equals 2 over 5. And then to work out this angle, let's call it theta, we would do theta equals inverse tan of 2/5. Okay, we access that by doing shift and then hitting tan 2/5, which is 21.8. And then we're going to take that away from that total angle, which was 120. So 120 minus 21.8, dot, 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 120 minus the answer is 98.1985, dot, 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 which to 3 significant figures, my imaginary line goes here, the 9 would round that 1 up, so it's 98.2 degrees to 3SF. Okay, so 98.2 degrees. And on to question 11. So, the cumulative frequency table shows information about the ages of 60 people who went to a gym on Saturday. So on the grid, draw the cumulative frequency graph. So from 10 to 20, so by the time we get to 20, I've hit 13. So 20, I'll have a mark at 13. From 10 to 30, so by the time I got to 30, we've got 36 here. And then 42, 47, so 42, 47, and then 52, 56, and 60. Okay. Now all cumulative frequency graphs should be this sort of curve, making sure you pass through all the points. Don't leave it in doubt. Something like that. Okay. And in part B, we're being asked to work out the median for these people. So if we have 60 people in total, the median is going to happen around about the 30th value. So go across from 30 and then down. Obviously, I would like to use a ruler to do this. I'm not going to get it out now. So this is about 26.5, 27. I'm going to call it 27. Okay. I think you were awarded with anything between 26 and 28 sort of thing for this question. And for part C, find the interquartile range. So now we're using our quartiles, so that's 3/4 of the way along, so from 45, oops, which is here, and down. So here we've got 46, and our lower quartile, looks to be 21. So 46 minus 21 is 25. And again, I think anything from 24 to 26 would have been rewarded with the mark here. Use your graph to find an estimate for the number of people who are older than 55. So now we go the other way. We go up from 55. And I'm just putting these arrows in so that it's clear which way I've gone before. But now I'm going the other way. So I'm going up from 55. Here we are. And that looks to me to be around about 50, 49 sort of thing. So I'm going to just say this is 50. So 60 minus 50, because we're looking for above, older than 55, leaves me 10. But I think anything 10 or 11 would give you a correct answer here. Okay? Okay, and on to question 12. So here, it might not look it, but we have two similar triangles. And these are similar because we've got opposite angles here, alternate angles between A and E, and also alternate angles between D and B because of these parallel lines. So if I draw these out side by side, which I always recommend doing when we've got similar shapes like this, so let's say this is D, E, C, and then next to it we have a smaller A would be in this bottom right side, B and C. Then this length is 1.2, this is 6, and we then have 2x and 2x plus 9 here. So what's my scale factor going between these? Well, 6 divided by 1.2 is 5, so I am timesing by 5 in each of these cases, which means that to go from 2x to 2x plus 9, I must be timesing by 5. So 2x times 5 must equal 2x plus 9. So 2x times 5 is 10x, equals 2x plus 9. And then I can take away 2x from both sides. So 8x equals 9, and then x is 9 over 8. Okay? On to question 13. So in question 13 we have a sector. So here we're being asked to work out the perimeter, and that's not just this length, this arc length, but it's the whole way round. And we'll start with the arc length, but then we'll carry on with the full perimeter in a second. So this is not a full circle, it is 67 degrees of a 360 degree circle. So instead of working out 2 pi r for the full circumference, I need to do 67 360ths of this for just that bit of the arc. So if my radius is 5.2, this will be 67 360ths of 2 times pi times 5.2. So let's type that in on my calculator and see what we're left with. Times 2 times pi times 5.2, which is 6.0807 ... But this isn't the full answer here. I need the full perimeter. So this length, which is 6.08 ... add 5.2, add this length. And this is just another radius, so this will be another 5.2. So if I take this, add 5.2, add another 5.2, I should get my total perimeter. And this comes out to be 16.4807 ... We want this to 3 significant figures, so let's draw an imaginary line after the first, second, third significant figure. 8 will round that 4 up to a 5, 16.5 centimetres to 3SF. On to question 14. Chiara throws 4 fair 6-sided dice. The faces on each dice are labelled with the numbers 1, 2, 3, 4, 5, 6. Work out the probability that at least one of the dice lands on an even number. Okay, so I think there's a couple of things going on here. We have 4 events, and we need to reduce this probability down to whether it's an even number or an odd number, because if we start by doing 6 events as a tree diagram and there are 4, this is happening 4 times, we are going to massively run out of space for this. So I'm just going to think about this as either being odd or being even. Okay, and this is just going to boil down to 50-50 chance, a half and a half, or 3 out of 6, 3 out of 6. Okay, even, even, even. Okay. Now I could work out all of these various combinations, but actually a much easier way of doing this is to say, well, the probability that at least one is even, well, the opposite of that happening is if it's odd every single time. So that's odd, then odd, then odd, then odd. So the correct probability would be 1 minus the probability of 4 odds in a row. Okay, so this is going to be 1 minus a half times a half times a half times a half. Okay, so this is 1 minus 1 over 16, 15 over 16. And as I said, there are various other ways you could have worked this out. You could have thought about the whole tree diagram and everything like that, but it boils down to 15/16. Okay. On to question 15. So we've got a kite and we're being asked to work out the area of the kite, giving our answer to 3 significant figures. So the first thing I'm going to do is draw this cut this in half. Okay? Because now I can think about this as 2 identical triangles. So the area of this triangle, ABC area, is using the formulae in our formula book right at the top. Let's get all the way back up to the start. Okay, here's my triangle. The area of a triangle is a half AB sine C. So if A is here, B is here, C is here, it's the angle in between A and B. So what I can do is I can quickly get back down to this question. We've got the 2 sides and the angle in between them. It's going to say the area is going to be a half times 6 times 11 times sine of 118. And that will be the area of this triangle. So actually the area of the whole thing will be 2 times half times 6 times 11 times sine of 118. And I can just cut out the middleman here. The 2 times a half will cancel each other out. So I can just do 6 times 11 times sine 118. And we get our answer of 58.2745 dot 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 dot, or just 58.3 to 3SF, which I think the question asked for. Yes, correct, to 3SF. On to question 16. Now we have some graphs, 9 graphs being shown here, and it says complete the table below with the letter for each, for the letter of the graph that could represent each of these given equations. So let's start with this top one. This is a straight line graph because it's in the form of y equals mx plus c, where we have a positive y-intercept, so something like that, but a negative gradient. So I'm looking for something that might resemble that sort of shape. So here we've got a negative graph, but it doesn't have a positive gradient, so it's not G, but it could be C, couldn't it? There's a negative gradient passing through a positive line, so we're going to put C for this one. Okay. Now, y equals minus 1 over x. Now, I know that 1 over x looks like this. So if I times everything by minus 1, well, what's going to happen here is it will be reflected in the vertical direction. Okay, so it will look something like this. So which graph looks like that? Here we are, F. Okay, so F is going to be the next one. On to this tan graph. So the tan graph has lots of asymptotes. It starts here and goes all the way up, and then we come back down, and then we go up again, and then up again, and so on and so on and so on, and it's this ever-repeating cycle. Oh, bless me. So, which graph looks like this? Here we are. Here's our tan graph. So, this is graph D. And finally, y equals x plus 1, x minus 1, x minus 2. This, if you expand it all out, is going to be a cubic because you've got an x times an x times an x. So it's going to look like this sort of shape. And if you think about how we draw quadratics, if we drew y equals x minus 1, x plus 1, well, that would equal 0 when x equals 1 or minus 1. So here I know that at x equals minus 1, I've got a root, and at x equals 1 and at x equals 2, I've got a root to this. So my graph, in a way, if I draw this through here, it's going to look something like this, where it's passing through at minus 1, at 1, and at 2, because it's a positive cubic, because it's x times x times x, and we've got roots at minus 1, 1, and 2. So let's see if we've got anything like that. Straight away, here we are. This is our only cubic graph, so I didn't even need to worry about the roots. H is going to be the answer here. Okay. And question 17. Use algebra to show that 0.345, now these dots mean this is 0.3454545 going on forever, equals 19 over 55. So again, it's a show that question. We pretend we have not seen this, okay? But we hope that our answer comes out to look like this. And the way we start this off is to say that x is this expression. And then we're going to form two similar expressions where the thing after the decimal point is the repeating part of this. Okay? So I'm going to start by saying 10x equals 3.454545 going on forever. Now if I then worked out 100x, it wouldn't quite be the same. So I'm just going to show you here. This would be 34.5454. So you see they don't marry up slightly. So this isn't quite there. If I turn this into 1000x, then it would be 345.4545 going on forever. And now if I subtract these, then all of this recurring nonsense will disappear. And essentially we have 1000x minus 10x for 990x, 345 minus 3 for 342, and nothing after the decimal point, which means that x, dividing both sides by 990, is 342 over 990. And at this stage, we could just simplify. So 342 divided by 990 equals 19 over 55. Okay, which is what we needed to show. Okay. On to question 18, our upper and lower bounds question. Also a compound measures question to do with speed, and there's almost always a question on speed and meters per second or kilometers per hour. So let's have a look at this one. Caden and Sonia went on 2 different car journeys. For Caden's journey, the distance he covered was 80 kilometers, correct to the nearest 5 kilometers. So if it's correct to the nearest 5 kilometers, then this could be anything between an upper bound of 82.5 and a lower bound of 77.5. Divide the nearest or the degree of accuracy by 2 and add or subtract that amount. For example, when we're doing it to the nearest 1 decimal place for 2.7 hours, so upper bound for 2.7, that's to the nearest 0.1, so we would add 0.05 for the upper bound, so 2.75, and our lower bound would be 2.65. Okay? And for Sonia's journey, we'll have, again, to the nearest two significant figures, so this has been rounded to the nearest 1, so upper bound would be 33.5, lower bound would be 32.5, and time is 1 hour correct to the nearest 0.1 hour, so again half this, 0.05, our upper bound is going to be 1.05, and our lower bound is going to be 0.95 hours. Okay? You could turn these into minutes and things, but I'm just going to use an average of kilometres per hour, as these are both in kilometres per hour. Now, Caden says, my average speed could have been greater than Sonia's average speed. By considering bounds, show that Caden is correct. Okay, so what's the maximum for Caden? Well, it's going to be the largest, because in terms of speed, is going to be kilometres per hour. So I want my upper bound for speed, so, or kilometres, okay, so that's 82.5. And to make this as big as possible, I actually want to divide by the smallest value for time, so divided by 2.65. And conversely, the lower bound for Sonia is going to be the smallest value on the top, so the smallest distance, so 32.5, divided by the largest amount of time, so 1.05. Okay, so let's work these out. 82.5 over 2.65 is 31.132 ... and I'm going to put these as decimals because I think it's easier to compare them. And 32.5 over 1.05 is 30.952 ... So we can quite clearly see that this is a larger. So I'm going to say 31.132 is greater than 30.952. So Caden is correct. Okay, which is what we needed to show. Okay, on to question 19. So f of x is x squared minus 4 and g of x is 2x plus 1. Solve f of g of x is greater than 0. So this is basically f of g of x is greater than 0. Okay, so what is g of x? So this is f of 2x plus 1 being greater than 0. And this means instead of f of x being x squared minus 4, instead of x, it's 2x plus 1. So this is 2x plus 1 squared minus 4 is greater than 0. Okay, so it says show clear algebraic working. So I'm going to now expand this as two double brackets. So 2x plus 1, 2x plus 1 minus 4 greater than 0 to give us 4x squared. It's this one, plus 2x plus 2x plus 1 minus 4 is greater than 0, and therefore 4x squared plus 4x minus 3 is greater than 0. Now this is a quadratic inequality, so we need to solve it in the same way as if it were equaling 0, how we would solve it. You can either use the quadratic formula, or you can factorise. I've seen how this can factorise, so 2x, 2x, and I want plus 6, so plus 3 minus 2 to get that 4x in the middle. It's going to be plus 6x minus 2x for that 4x in the middle. So here x equals, or 2x minus 1 equals 0, or 2x plus 3 equals 0. So 2x equals 1, or 2x equals minus 3, and x either equals a half or minus 3 over 2. So graphically, what does this look like? Well, it's passing through at minus 3 over 2 here, and at a half. It's a positive quadratic, and we're looking for where this quadratic is greater than 0. So that's going to be this part of the graph and everything beyond, and this part of the graph and everything beyond. And if we think about this squashed down a little bit, that's everything on the outside. So anything to the left of minus 3 over 2 or lower than minus 3 over 2. So x is less than minus 3 over 2, or x is greater than a half. Okay. On to question 20. The centre O of a circle has coordinates 4, 7. Okay, let's draw this out. So this is 4, 7. And the point A on the circle has coordinates 6, 11. Okay, so that's going to be over here and up here maybe. 6, 11. This is the point A. This is O. And AOP, so AOP is the diameter. So P is going to be down here somewhere. Okay. Find an equation of the tangent to the circle at the point P. So the tangent of the circle is going to be this line here. Now I know from circle theorems that this is going to be perpendicular. So what I need to do is first I need to work out what the coordinates of P are, and then I need to work out what the gradient of this line is, so I can work out what the gradient of this line is, and therefore work out the equation of that line. So I'm just going to use sort of basic maths to work out what the coordinate of P is. To get from O to A, I go 2 to the right, so I must go 2 to the left to go to P, so this is at 2. And I've gone from 7 to 11, so I've gone up 3. Sorry, no, I've gone up 4, so I need to go down 4. So P has coordinates 2, 3. Now the gradient of this line is the rise over run. So M of PA, let's say, is the rise. So in fact, I'll just do PO. Is the rise, so 3 to 7 is 4, over the run 2 to 4 is 2, so 4 over 2, that is a gradient of 2. And therefore the gradient of the tangent is going to be the negative reciprocal, so that's minus 1 over 2 for this line down here. And if we are working out the equation of it, there's two ways of doing this. We can either say y equals mx plus c, because that's the equation that it's got to be in, and plug in some values. So a y coordinate 3 equals minus a half gradient times your x coordinate 2 plus c, to work out what our y-intercept is going to end up being. Okay, so plug this in. This is going to be minus a half times 2 is minus 1, plus c equals 3, and therefore c equals 4, y equals minus a half x plus 4. And once we found that plus 4 out, I know where it goes. But another thing that you could have just done, if it's just asking for an equation of a tangent, is if you come across the y minus y1 equals m brackets x minus x1 formula, you could have just thrown everything into here straight away. Here you have a coordinate which is x1 comma y1 and a gradient of m, so this is just y minus 3 equals minus a half brackets x minus 2. And if you multiply all of this out, you'll get the same answer, but this is also a valid equation that you can leave as a final answer. I'm going to just put the y equals minus a half in here though. Minus a half x plus 4. All right. On to question 21. And we have a very standard question here, simultaneous equations, but this time we have a quadratic to solve as well. So let's rearrange this, because whenever we've got a quadratic to solve, we have to end up substituting it in. So x equals 3 plus 2y. And I'm going to substitute this in every time I see x in this second equation. So instead of x squared, I'm going to think about this as 3 plus 2y squared plus, minus y squared here, plus 2x, so plus 2 times 3 plus 2y equals 10. And solve this equation. So, double brackets for the 3 plus 2y, minus y squared, plus 6 plus 4y equals 10. Now expanding this out, we have 9 plus 6y plus another 6y plus 4y squared minus y squared plus 6 plus 4y. And because this is a quadratic, I'm going to bring everything onto the same side. So minus 10 equals 0. And now collecting terms together, y squareds, 3y squared. We've got 6y, add 6y for 12y, add 4y is 16y. And then I've got 9, add 6, minus 10 is 5, so plus 5 equals 0. Now straight away I can see how this can factorise again, but you can use the quadratic formula. So I want 3, I know this is a plus plus, 3 times 5 for 15, and plus another 1 equals 0. So y, or 3y plus 1 equals 0, or y plus 5 equals 0. So y equals minus 5, or 3y equals minus 1, and y equals minus a third. But we're not quite done there. I'm now going to substitute it into this equation here, x equals 3 plus 2y. So x equals 3 plus 2y. So this is 3 minus 10. X is going to be minus 7 for this one. Whereas for y equals minus a third, x equals 3 plus 2 times minus a third. So 3 minus 2 thirds. So that's 7 thirds. So our coordinates, or our, does it ask for coordinates? No, there's no coordinates here, it's just interpreting this logically. So either x equals 7 over 3 and y equals minus a third, or x equals minus 7 and y equals minus 5. Okay, two sets of solutions, or two pairs of solutions. Okay, on to question 22. Nearly there now. The point A with coordinates minus 3, 2 lies on the straight line with equation y equals f of x. Find the coordinates of the image of point A on the straight line with the equation f of x minus 3. So this is everything being translated down 3. So our minus 3 will stay the same, but our y coordinate is going to decrease by 3. It's going to go down to minus 1. Okay. Now, inside the brackets means we are doing things horizontally, not vertically. And it also means we're doing the opposite to what we might think. So this is actually being stretched out by a factor of 2. So this minus 3 coordinate will become minus 6. And our y coordinate would just stay the same. It would be 2. Okay. Here is the sketch of part of the curve with the equation y equals g of x, and we've got the coordinates which has points P and Q. Find the coordinates of the image of the point B on the curve with the equation y equals minus g and then x minus c. So this is f of x minus c. So again, if it's inside the brackets, it's going to be going horizontally and it's going to be doing the reverse of what we think. So this is actually going to be going to the right plus c. So our p coordinate, our x coordinate, is going to now become p plus c. Okay, and this g on the outside, okay, sorry, this is, yes, so it started off with g of x, so now it's become minus, so let's call this, this is like saying y equals minus h of x, so it's on the outside. This is actually a vertical thing and it's going to be a flip, okay, so it's like a reflection, so this is going to go over onto this negative side, so q becomes minus q. Okay, hope that makes sense. Anyway, next, question 23. So the first thing we need to recognise with question 23 is that actually what we've got here is the difference of two squares. So rather than when we're trying to combine these two fractions, just blindly timesing this fraction by x minus 6 and this fraction by x squared minus 36, we could make life a lot easier for ourselves by thinking about this as x plus 6, x minus 6, minus 2 times x minus 6, okay, times 1 over 4 minus x. So all I actually need to do is multiply this bracket on the right, or this fraction on the right here, by x plus 6. So minus 2x plus 6 over x minus 6, x plus 6, and 20 over x plus 6, x minus 6. And this now means I can combine my two fractions. So this is 20 minus 2 brackets x plus 6 all over x plus 6, x minus 6, and then this times 1 over 4 minus x. So I'm going to expand this on the top. Now look out for this negative. This is going to produce a minus 12. So 20 minus 2x and then minus 12 over x plus 6, x minus 6 times 1 over 4 minus x, for 8 minus 2x over x plus 6, x minus 6 times 1 over 4 minus x. Now, I am running out of space a little bit, so I'm just going to cut this in half as much as I can. Now, you might not think this simplifies any further, but actually what we can do is we can factorize this top here. Now, 2 is a common factor of 8 and minus 2x, so let's take it out. 2 into 4 minus x up here over x plus 6, x minus 6 times 1 over 4 minus x, and we can now see that these will cancel, leaving us with 2 times 1 on the top, so just 2 over x plus 6, x minus 6. Okay, so this will be my answer. 2 over x plus 6, x minus 6. And you could multiply that out again to x squared minus 36, but I don't necessarily feel you have to. Okay. On to the penultimate question, and one of the harder ones, I should say, in the question. This was a 6-marker, the one worth the most throughout the whole paper. So let's see what's going on. We have a diagram showing a frustrum, which is basically a cone with the top bit cut off, and a sphere, which is going to end up being cut in half. The height of the small cone, so this one at the top, is h, and the radius of the base of the cone is r. The height of the large cone is kh, so that our scale factor is k here, so it's kr as the radius as well. The sphere is divided into two hemispheres, both of radius r, so that we get these two shapes, A and B, being formed. And we are told that the volume of A, this larger one, is 6 times the volume of solid B. So this equals 6 times this. Okay. Given that k is greater than the cube root of 7, that might be relevant at some stage, but we can just ignore it for now. Find an expression for h in terms of k and r. So I think the first thing we need to do is try and find some form of expression for these two shapes. So let's start with this cone, shall we? Now, all of these formulae are at the front of the book. I'm not going to keep racing up and down to find it. You'll just have to take my word that the volume of a cone is 1/3 pi r squared h. Okay, it's basically the base times the height and 1/3 of it. Okay, so if our radius is r and my height is h, then the small cone will have a volume of 1/3 pi r squared h, which means the frustum, or let's do the large cone first, would have a volume of 1/3 pi. Now this radius is kr, yeah, so kr squared times h, and this times its h is kh. So 1/3 pi r, so kr squared, times h, so times kh. Okay. And the volume of the frustum, therefore, is going to equal this, so 1/3 pi, and I'm just going to expand this now. This is k, or let's write it all out, so 1/3 pi k squared r squared times kh. So in fact that will be k cubed, wouldn't it? So it's 1/3 pi k cubed r squared h minus the volume of that smaller one, 1/3 pi r squared h. Okay. And the only thing we're now really missing is the volume of a sphere, and therefore a hemisphere. So the volume of a sphere, again, this is at the front, but you can take my word for it that it is 4/3 pi r cubed. So the volume of a hemisphere is going to be 1/2 of 4/3 pi r cubed, or 2/3 pi r cubed. So now we can form our equation where these two equal each other, or this equals 6 times b. So the area of this of A, I'll just do this above, is going to be 2/3 pi r cubed plus the volume of the frustum, so plus 1/3 pi k cubed r squared h minus 1/3 pi r squared h. And we're told that this equals 6 times b. And b is going to be the small cone. Yes, this small cone, so 1/3 pi r squared h plus that hemisphere again, so 2/3 pi r cubed. And now we need to multiply it out, and we are trying to find an expression for h in terms of k and r. So we want the end game to be h equals something. So multiplying everything through, let's multiply this out. So 6 times a third is 2. So this is 2 pi r squared h. And 6 times 2 thirds is going to be 4. So plus 4 pi r cubed. And we've got all of this on the left hand side. In fact, something I might do here is just press equals below and start rearranging. Now we're trying to get h equals, so I'm trying to get h on one side. So let's take away 2/3 pi r cubed from this 4 pi r cubed. In fact, what I could do is just divide everything through by r squared. Everyone's got at least an r squared involved, and everyone's at least got a pi in each term. So let's do that actually before we do anything else. So 2/3. Now r squared, or r cubed divided by r squared, is just going to be r plus 1/3 k cubed, and then divide by r squared, so h, and then divide by r squared, so minus 1/3 h equals 2h plus 4r. Okay. And I'm actually also going to multiply everything through by 3, so I don't need to worry about fractions anymore. So 2r plus k cubed h minus h equals times by 3, 6h plus 12r. So take away 2r, and we want all the h's on this side. So k cubed h minus 7h equals 10r. Okay, now to make h the subject, we need to factorize it out. H into k cubed minus 7 equals 10r, and then h equals 10r over k cubed minus 7. And this is, I guess, why I've got the k has to be greater than the cube root of 7, because if k equaled the cube root of 7, we'd be dividing by 0. So 10r over k cubed minus 7. Okay, on to the final question, and vectors. So this was one of the trickier vector questions that I've come across, but it is doable, so let's do it. So let's use all the information. So I know AB is A, and therefore DC is also A, because this is a parallelogram. And similarly, here we've got B, we've got B, we're told D to M is a half B. Okay, now AK to AB, so AK to AB is in the ratio of lambda to 1. So if the whole length is A, then this is going to be lambda A up to K, and various ways of working this out, but K to B is going to basically be minus lambda A plus A, so minus lambda A plus A, for example. And we can do a similar thing here, but it would be going the other direction, because we're going from CL to and CD. So this would be minus mu A, and then from here to here, think about this as plus mu A, so mu A minus A. Okay, and then we've got KLM is a straight line, where if that's a particular rule, then KM is going to equal some multiple of KL, so let's just call this X times KL. And finally, lambda to mu is in the ratio of 1 to 2. So if lambda over 1 equals mu over 2, then we essentially know that 2 lambda equals mu. And actually, once we've got that, we could rewrite a lot of this, and it could make life a lot easier. So in fact, that's what I'm going to do straight away. I'm going to change this minus mu a to minus 2 lambda a. And I'm going to change this mu to 2 lambda a. Okay? And now everything in here is all in terms of lambda, and all I need to do is use this relationship to work out what the value of lambda is, and then conversely what mu is going to end up being. Okay? So let's work out an expression for KL. So KL is going to be minus lambda a plus a plus b, and then minus 2 lambda a. So this is minus 3 lambda a plus b, or a into minus 3 lambda plus 1 plus b. Okay, and now if I do k to m, because we're going to be using this relationship here, well, this is going to be minus lambda a plus b, going along here, plus a half b. Okay, or in other words, minus lambda a plus 3 over 2b. Okay, now remember, I know that km, so minus lambda a plus 3 over 2b equals x times a 3 minus 3 lambda plus 1 plus b. And if we think about these components, well, the b component here, okay, when I multiply this out, means that I have to be left with x equaling 3 over 2. Okay, so x equals 3 over 2, meaning minus lambda a, if I just focus in on the lambda parts of this now, will equal 3 over 2 a minus 3 lambda plus 1, and therefore let's expand all of this out. So minus 3 times 3 is minus 9 over 2 lambda a plus 3 over 2 a. In fact, let's just get rid of the a's now, I think. So minus lambda will equal minus 9 over 2 lambda plus 3 over 2. Let's get rid of the denominator, so times everything 3 by 2, so minus 2 lambda equals minus 9 lambda plus 3. Add 9 lambda, so 7 lambda equals 3, and lambda is therefore 3 over 7. And if lambda is 3 over 7, then mu has to equal 2 times lambda. Mu is 6 over 7. There were various ways to do this question, but I think that's probably the easiest way to go about it. Compare parts of a journey. The sooner you unlocked this, the easier you could make the overall problem by just making it all in terms of lambda, or all in terms of mu if you did it that way around. I have to admit, this was my second go. I left this relationship till right at the end, and my algebra was a lot more messy. But I did get the right answer in the end. These are the correct final solutions. Okay.